Today I'm going to teach you how to solve the large equations. I like to call these the big uglies. Anyway, we're going to do part one without the fractions, and then my next video will be adding the fractions. Here are the only 4 steps you need to know. Number 1, you're going to get rid of any parentheses using the distributive property. Number 2, you're going to simplify each expression on either side of the equal sign. Remember, simplifying is devoted only for expressions. Third, if you have any terms on both sides that include the variable, you're going to add or subtract one of those terms so that you only have the variable on one side of your equation. And then number 4, you're going to have a 1 or 2 step problem left to solve. All right, here we go. Let's do some examples. Step 1, let's get rid of the parentheses using the distributive property. So I am going to show my arrows. Again, you don't have to show your arrows if you can do this in your head. I'm going to do this plus 2x plus 8 and then equals. And on this side, you see how I have a negative in front of the parentheses? Remember, that's a -1. So I'm distributing -1 to both. So I'll have that -7x. -1 times x is just -1x. I'll keep it that way. And -1 times +1 is -1. All right, there you go. Step 2, I am going to simplify each side of the equation. For the left-hand side, I have 2 terms that have x. So -4 plus 2 is a -2x plus 8 equals. And then here I also have 2 terms that have x. So a -7 and a -1 gives me a -8x minus 1. All right. Step 3 is to find out that, yeah, I do have an x term on both sides. So let's get rid of one of them by adding or subtracting. I'm going to get rid of the -8x. How do I get rid of a negative term? I do a positive term. So I'm going to do a positive 8x here and positive 8x here. I'm lining up like terms. These are going to go away. And over here, I'm going to have, it looks like a 6x plus 8 equals, and on this side, a -1. Okay, let's finish this. -8, -8. And I'll have 6x equals -9 divided by 6 divided by 6. And it looks like my x is going to equal -9.6, which is the same thing as just -1.5. All right. How would I go about checking my answer on such a big problem? Well, it's the same as what I've showed before. So I'm going to erase this and show you how. I'm going to put -1.5 everywhere that I see an x. And then I'm going to calculate each side individually to see if both of them come up with the same number. So here we go. Here's the first side. And when I put it into the calculator, out comes an 11. Now let's do the other side. Sure enough, when I put the second side into the calculator, I also got an 11. And so if both sides equal the same amount, then my check worked and my answer is correct. All right, let's go on to another one. Stop the video, do this on your own, then come back and see how close you were to the right answer. All right, here we go. Step 1, let's get rid of the parentheses using the distributive property. So I have a -10x plus 9x plus 12 plus 1 equals, looks like -21x minus 9. Is that what you got? All right, next step. I'm going to combine like terms on each side to basically simplify each expression. So I have this, which is a -1x, or just -x. And then I have this, which looks like a 13, so plus 13. Over on this side, oh, it's already simplified. Woohoo! All right. Next step, I'm going to get rid of the terms. I have x's on both sides. I want to get rid of one of those terms. I'm going to go ahead and get rid of the -21x by using a positive 21x. Those should cancel each other out. All righty. And then just remembering this is a 1. All right. This goes away. And I have a 20x plus 13 equals, well, all that's left over there is a -9. And woo, I'm back to a 2-step process. -13, -13. I have a 20x equals a -22, right? Divided by 20, divided by 20. And so I could say x equals negative. I'm going to simplify that to 11/10. Or you could even call that negative 1.1. All right, let's go on. I really want you to see that I'm doing the exact same thing every time. Pause the video, try this one on your own, and come back because this has a funky answer. All right, here we go. Distribute. So I have a positive 8x plus a 14 minus a 1. And over here I have a 5x plus 3x plus 12. Next, combine like terms. Simplify each side by itself. So I have an 8x plus 13. And I have an 8x plus 12. Oh, they both have 8x's. That's fantastic because I know what's happening. Do you yet? So when I get rid of, I can't have x's on both sides. And when I get rid of the 8x's here, they go away over here just because they're both 8x's. So I'll bam, gone, bam, gone. And what I have left over is I have a 13 equals 12. Now, ladies and gentlemen, is that a true statement? Does 13 equal 12? No. And so do you remember what that's called? That's called no solution. And basically what I'm saying here is there is absolutely no number in the entire universe that is going to make that equation true. It's just not possible. Why? Well, look right here. I know I've written over it, but I'm multiplying a number times 8 and adding 13 on one side. I'm multiplying the same number times 8 and adding only 12. How can that ever equal each other? It can't. No solution. All right, one more to go. All right, pause it, do it on your own, then come back. Here we go. First thing, distributive property. Getting rid of all those. So I have a negative 6x minus 8 plus 8 equals negative 4, and then that's a negative 2. Don't forget that. Not just a 2, but it's a negative 2. So negative 2 times 3x is negative 6x, and negative 2 times a negative 2 is a positive 4. Next step, combine like terms on each side of the equal sign. So here, these are like each other. So I'll have negative 6x, plus 0, right? So boom, done. Equals, and over here, this guy and this guy, their two constants are like each other. Check that out. And then I have a negative 6x. Well, what does that mean? They're identical sides. Well, I could go ahead and subtract one x from the other, and then I'm going to get a 0 equals 0, but I can stop right here. Y'all, you can stop right here because you're doing the exact same thing to both x's. And if you do the same thing to the x on one side of the equal sign and the same thing to the other, I can put any number in the world in there and it's going to work. So this is infinitely many solutions, which takes me way longer to write than to say. All right, there you go. Now you're ready to do some basic, big uglies. It's just that these are not going to have fractions. Wait till the next video. We'll see you soon. Bye.